Good day, everybody. How are you all? This is Dr. Nandi. Today we are going to solve a system of equations by matrix method. So I'll share my computer screen with you. They solve the system of equations 1 over x plus 3 over y minus 1 over z is equal to 5, 2 over x plus 4 over y plus 6 over z equal to 4, and 7 over x plus 3 over y plus 1 over z is equal to 3. So we're going to solve for x, y, and z. Now, solution. Let 1 over x is equal to a, 1 over y is equal to b, and 1 over z is equal to c, where a, b, and c are unknown variables, and c are unknown variables. Thus, when we substitute for 1 over x, and the first equation becomes a plus 3b minus c is equal to 5. Next one becomes 2a plus 4b plus 6c is equal to 4, and 7a plus 3b plus c is equal to 3. Actually, the first equation, I've copied it wrong, so I'll correct it. First, I'll erase this. So this is over here is wrong. It's 2 over x. This is wrong too. So now I will go to the black pen and correct this one. This is 2 over x, not 7 over x. 2 over x. And then I'll go to the red pen. So this is 2 over a, the last one, not 7 over 2a, because the first equation is 2 over x. Maybe I like to write it a little bit correct, so everybody understands. It's 2 over x. Okay. So we have the unknown variables a, b, and c. Now in the matrix form, this can be written as 1 is the coefficient of a in the first equation, 3 is the coefficient of b in the first equation, and minus 1 is the coefficient of c in the first equation. Similarly, coefficient of a in the second equation is 2, coefficient of b is 4, and coefficient of c is 6. And coefficient of a is 2 in the third equation, coefficient of b is 3, and coefficient of c is 1. So this is the coefficient matrix times a, b, and c. This is a 1 column, 3 rows by 1 column matrix. A, b, and c is equal to the constant terms, which are 5, 4, and 3. Again, this is a 3 row and 1 column matrix. There's 5, 4, 3. So if I create some space for myself, this can be written as, okay, going back to the A times, you can call this A, B, and C, maybe small a, is equal to C. So matrix A times matrix A is equal to matrix C, where A is equal to 1, 2, 2, 3, 4, 3, and minus 1, 6, 1. It's a coefficient matrix. This is matrix A, and matrix small a is equal to matrix. It's a single column 3-row matrix, 3-row by 1 column. And C is the constant matrix, which is also single column 3-row matrix, 5, 4, and 3. Okay, now I will create some more space. So since matrix A times matrix A, small a, is equal to matrix C, then matrix A, which is the solution we are looking for, is we are multiplying by A inverse on both sides, equal to C. Or we are dividing by A on both sides. So this is the solution we are looking for. Okay. So what does it entail? We have to find the inverse of the matrix A. Okay. So I've already written what is matrix A. So let me again write it. Matrix A is equal to 1, 2, 2, and 3, 4, 3, and minus 1, 6, 1. 6, 1. That's your matrix A. Okay. So we will use TI-84. Okay. How will I use TI-84? Okay. Okay. So get some space. Okay. So press second button, then X minus 1 button, then highlight edit on the top row, and the second button, X minus 1, highlight edit, and then number 1. And when you do that, enter number 1, and enter number 1, and enter. And make matrix A, 3 row. The first number is row by 3 column. And then enter the coefficient matrix in matrix A. So matrix A is this. Okay. Now we need to find out the inverse. So we are entering the components of matrix A in this 3 by 3 matrix A. Okay. To find after entering the components of matrix A, we need to find the inverse, find A minus 1, or inverse of matrix A. inverse of matrix A. How to do it in the calculator. So, okay. Again, use TI 84. Press second button, then X minus 1 button. The second X minus 1 button, and then number 1. So first you have to put the calculator off, remember, before doing that. So second X minus 1 button, then number 1. And you'll get, this will lead to matrix A on your calculator key. Okay. Then press the X minus 1 button. Okay. When you do that, you will get an exponent of minus 1 here, and then hit enter. So basically, you will not get the inverse matrix of A is equal to, this will be your inverse matrix, 0.7, actually it is minus 0.777 minus 0.333, and then 1.222. Next row is 0.555, 0.555, then 0.166, and then it is minus 0.444, and the last row is minus 0.111, 0.166, and minus 0.111. So this is your inverse matrix. Okay. Okay, now we will enter this data in matrix B in our calculator. How to do that? So let me create some space. Okay. Enter components of matrix of A inverse in matrix B in TI 84. How to do that? Press second button, then X minus 1 button, and then edit. Okay, then number 2. So second X minus 1 button, edit, then number 2. Okay, so number 2. So this will lead you to matrix B. Make it a 3 row by 3 column and enter as matrix B is equal to minus 0.777 minus 0.333, 1.222, 0. So it's a 3 by 3, right? 3 rows by 3 column with these components, 166. Sorry, I'll erase that. Too good. So 0.166, and then minus 0.444, and then minus 0.111, 0.166, and minus 0.111. So these are the components of matrix B. Now we have to enter the information for the constant matrix. Remember, it shows the constant. What are the constant terms on the right hand side? Is 5, 4, and 3. 5, 4, and 3. Okay, remember that. Oops, sorry. 5, 4, and 3. Okay, so let me write it down. Enter components of matrix C in PI84. So how do I do that? Again, second button, X minus 1 button, then highlight edit, and number 3, so matrix C, uh, second X minus 1 button, then edit, then number 3. Remember, it is a 3 row by 1 column. So it is a 3 by 1 column. And what is it? Is 5, 4, and 3. So enter this information. 5, 4, and 3. This is your matrix C. Okay. Why did you do that? Because your solution matrix. Let me change the color of the key. So remember, the solution matrix is A is equal to A inverse times C. And we have entered the components of matrix A inverse in matrix B. So B multiplied by C, matrix C will give you your solution matrix. Okay, so let's do that. So we are going to calculate, multiply matrix B times matrix C. B is actually the components of A inverse, and C is the constant matrix on the right hand side, which is 5, 4, 3. So let's calculate in our calculator. Press the second button, then math, then you'll select number 2, which will give you matrix B. Then you'll do the multiplication sign, which will give you the multiplication sign over here. And then second, math, and number 3, which will give here matrix C. And then you hit enter. Okay, so second X minus 1, then actually, I have made a little mistake, so let me correct myself. So we don't need the math actually, so let me erase this one. So we have to do matrix multiplication, matrix B times matrix C, because B is actually matrix A inverse. So how do I do that? So you'll do second button, X inverse, then X inverse button, then select number 2. Number 2 is in matrix B. Okay, number 2. Okay, and you'll get matrix B in your calculator screen. Then you do the multiplication sign. Okay, then you do the multiplication sign here, And then again you do second, x minus 1, and then number 3, which will bring matrix C. So multiplied by, okay, don't forget the multiplied by, then second x minus 1 and number 3, okay, which will bring C over there, and then enter. So your solution matrix is, create some space. So your solution matrix is matrix A is equal to matrix B times matrix C, and that is equal to minus 1.55C, 2.11, and minus 0.22. But this is same as A, B, and C, which is same as 1 over X, 1 over Y, and 1 over Z. Because remember, A is 1 over A, and B is 1 over Y, and C is 1 over Z. So, what's this? So the actual solution matrix, if I create some more space, and I go back to the heading. So actual solution matrix, X, Y, and Z. Where's this? So X, Y, and Z is equal to the solution matrix minus 1 over A, actually 1 over A, 1 over B, and 1 over C is equal to minus 1 over 1.556, 1 over 2.11, and 1 over minus 1 over 0.22. So if I take a little bit more space, so basically the matrix solution X, Y, and Z are the inverse of those numbers, which are 1.556 inverse is minus 0.6426, then 2.11, its inverse is 0.4739, and 0.22 inverse is minus don't forget the minus sign, is 4.545, minus 4.545, you might say. So this is your actual solution matrix, solution for X, Y, and Z matrix for X, Y, and Z. So to recapitulate what we did, we first said 1 over X is A, 1 over Y is B, and 1 over Z is C. And we plugged it in the original equation. So we wrote an equation, matrix form, matrix A, which is the coefficient matrix, multiplied by the solution A, matrix A, is equal to the constant matrix C. Now, if we divide by matrix A on both sides, we get matrix small a, which is the solution matrix, is matrix capital A inverse times the constant matrix. So the first thing is we wrote the coefficient matrix capital A, then we found the inverse of the coefficient matrix and multiplied the inverse of the coefficient matrix or matrix A minus 1 to the power of minus 1, multiplied it by the constant matrix to get the solutions. But these solutions are for A, B, and C. Remember, A is the inverse of X, B is the inverse of Y, and C is the inverse of Z. So, in other words, after finding the solutions, small a, small b, and small c, we have to invert them to get the actual X, Y, and Z, which we did in the last step. I'll stop here today. If you have any question, comment, please give me or please write me a note. I'll get back to you as soon as possible. And I appreciate it that you watched it. And if you like this video, please give me a thumbs up. That I appreciate it also. Please, if you like this video, share this video with your friends. And you and your friends, please subscribe to my channel by hitting the red subscribe button in the bottom right corner. I'll see you next time with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice day.